So today we're doing Leetcode Problem 200, number of islands. Given an m by n 2D binary grid, which represents a map of ones and zeros, return the number of islands. Let's just look at the example right away. So this first example, the output is one island, because here you can see that this first row, this is a portion of the island here on the second row. And if they're connected horizontally or vertically, if they're adjacently connected, then it's part of the island. So this portion is part of this main strip of the island here. And same with this portion and this portion. So this is one island. And that's why the output is 1. Let's look at the second example. This has 3 islands because this is one island here. So this group of 4 ones is an island. This one here is a single island, and then these last 2 are a single island. They're not connected diagonally. Like it says in the problem, only horizontally and vertically. So the way we're going to do this problem is this is a great DFS problem, right? The idea is that you have this global counter and you increment it whenever you see a 1. Then you run your DFS to explore the other portions that are connected to it. And then you sync the islands as you go. Like DFS uses some kind of visited set to make sure that you don't double count any places you've been to before. So what we can do instead is we can just sync the island, and by sync I mean set it to 0, right? And then we'll keep going until eventually it stops. And then we'll keep looping through the rest of the grid and looking for ones and calling DFS anytime we see them and making sure to increment our counter as we go. So let's just get started, and then it'll probably make some more sense that way. So let's do some error checking first. So if not grid or length of grid is 0, then we can just return 0, right? Like if the grid's null or if there's nothing in the grid, there's no islands. So it's 0. And then we can do, hey, the result is 0. This is the counter that we're going to be incrementing over time. So now let's write the shell of this main function that's going to actually call on our DFS, right? What the shell is going to do is, well, let's just write it out. Range, length of grid of index I. So what we're checking for as we're going through the grid, I'm doing this, cell equals grid of index I, j. If cell is equivalent to a 1, meaning if you find land, then we're going to call on DFS. But before that, let's increment our counter, because we know that we found an island. Let's increment the count of the number of islands we've seen, and then let's go and explore this whole island and sync it as we go. So now we can call on DFS, capitalize that. It's going to take in our grid and our position, because that's where we're going to begin when we call on this helper function, right? Now, when this finishes, we should just be able to return a result, and that's it. Pretty straightforward. So let's write out our actual DFS function. It takes in a grid, I and j, the position, and DFS uses a stack. So let's create a stack here, and this stack is what's going to be controlling our main condition, our main looping condition, to actually go through the neighbors. We're going to go through our neighbors and throw them onto the stack, right? So we have a stack. Let's append this current position to our stack, and I'm going to append it as a tuple. And now we can also sync the position that we're at and set it to 0, because we don't want to double count it. It's kind of annoying that you set it to, they give you this input of string representations of 1s and 0s. I wish Leetcode would just give a integer, but it is what it is. It's not a big deal. So now what we're doing here is, while the length of the stack is greater than 0, we're going to keep looping until we have no more neighbor islands to explore that are part of the original island piece that we found, right? We've appended to the stack. We're going to go through the stack, and then what we're going to do is like the current position that we're at is equal to the pop of the stack. So we're going to pop off the current place in the stack. And actually, before, what we're going to do now is we're going to loop through all 4 neighbors, right? We're going to check if if our neighbors are pieces of land. So an example is if we look at this portion over here, let's say that I found a, let's actually consider this part. Ignore the other portions. This highlighted portion here. Let's say I found a 1 and I want to check my neighbors. I would want to check this guy here, to my left, below me, and to my right. But you may want to make sure that you're not going out of bounds of the grid, because then you would get an index out of bounds. So for example, if I was here, since this is a 1, I want to check my neighbors, but you want to make sure that you're within the bounds of the grid. So not only do you want to make sure you're within the bounds of the grid, you also want to only consider your neighbor and put it on the stack if it's also a 1. So let's talk about how we're going to do that right now by just doing it. I like doing it this way, where I write a loop to go through all 4 adjacent neighbors, which is by using this list of directions. And the directions is just a list of lists, where really it's just what we're going to be adding to our row and column position, right? So -1, +1 in the row, and then same for the column, right? -1 and +1. Cool. Now for direction in, actually I'm going to say D in directions. We're looping through this directions loop, right? The actual row and column that we're now going to consider, like our neighbor row and neighbor column, is going to be the addition of this position with R and this position with C. So let's say row equals R plus D of index 0, because that's the first portion, the row column, the row portion of the direction. And then we can say column is equal to C plus D at index 1. So now, instead of writing a bunch of conditionals and calls to the 4 neighbors, I just have to write it once within this loop. So if you want, so this is the bounds checking. If the row is greater than or equal to 0 and less than the length of the grid, and the column is greater than or equal to 0 and less than the length of the grid at the index of the row, and our grid at the row and the column is equal to a piece of land, or a 1, then what we're going to do is we're going to append it to our queue, and we're also going to sync it, right? Because we saw that it's a piece of land and it's connected to our current island. So since we're connected, I want to make sure that I don't consider you again. Row column is equal to a 0 now, and that should be enough, I think. Let's check it. Let's run it. Yeah, that works. So let's submit this. Great. So the runtime for this, so what this problem is doing is it's looping through the entire grid. So out of n items in our grid, even though it's m by n, let's say that n is the total number of entries in our grid. we're looping through the entire grid and looking for ones, so that's O of n time. But then we're running a DFS every time we see a 1, so it's the runtime of DFS, which is O of v plus e, like vertices plus edges. So the total runtime is just the runtime of DFS. Yeah, that should be correct. Great. Thanks.